For our example number 2, we're gonna use the LCD screen that's in your kit. Make sure that you're using a potentiometer to control the light intensity in your display, and try to follow this schematic because it's the pins that I have connected in my example. So to include this LCD in our Arduino, we need to use the Liquid Crystal library. You don't have to download it because it's already included in your Arduino IDE. So it's include, then Liquid Crystal .h. That's gonna include the library for your LCD screen, and then we need to relate the pins to the liquid crystal because we can use 13, 7 or any other pins. That's gonna be then selecting them. It's some integers. So first we're gonna write const, and then we're gonna put the numbers for the pin. So rs equal to 12. So what I mean by this is that the pin rs in my LCD, it's connected to my pin number 12 in my Arduino. So 12 goes to RS. E is connected to 11. So we're gonna put enable equal to 11. Then all the other ones that I have here, 5, 4, 3, and 2, for data 4 to data 7. So data 4 is equal to 5, data 5 is equal to 4, data 6 is equal to 3, and data 7 is equal to 2. Now we need to relay those pins using the liquid crystal function. So it's liquid crystal, and every time that you write it, make sure that it's orange. That means that it's a function from the liquid crystal library LCD, and now we're relaying those pins. RS, which is pin 12, enable, D4, D5, D6, and D7. It's important that you write them in this order. If not, they won't work. And we need to initialize it. So in my setup, we're gonna write LCD begin. Then we need to specify the size of the LCD screen. So this one is a 16 by 2. 16 in the x-axis and 2 in my y-axis. So that's where you get that 16 by 2. So LCD begin a 16 by 2. Then let's say you want to clear your screen. So you need to write LCD that clear, and that will clear the screen. And then you need to specify where you want to start writing. So if I write LCD set cursor, it's not orange. That's because I made a mistake here. If I put 0, 0, that's a coordinate related to this point. So if I start writing, it's gonna start writing from this 0, 0. And then you need to tell it what you want to try. So LCD that print, and let's try hello. Let's upload it. Oh, it needs to be a string, so let's just put those double commas there. Okay, good. So it's writing hello. If I change this cursor from, let's try 5, it's gonna move my message. It's gonna clear first the hello that I have here. So let's try that. Let's just try to clear it. That's gonna erase my screen. Okay. Now if I put at 5, 0, it's gonna move 5 spaces to the right. 1, 2, 3, 4, 5. So it's gonna start here. And let's write test. There you go. Now if I try 13, it won't have enough space to write the whole text because that T would be in the 17 space, but we don't have a 17 space. 13, 14, 15, and we don't have a 16 because the 0 is the first space. So that's, just keep that in mind. If I put 13.1, it's gonna go one space below. So now it's taking the array in the bottom. Okay, so what we're gonna do here is that we're gonna try to find what's the light level that it's been read by this photodiode right here. It's not a photodiode, it's a photoresistor. So this one changes its resistance with respect to the light intensity. So we're gonna see that change using our LCD screen. Let's do an analog read first, and then equal to analog read. Let's choose A0, which is where my photoresistor is connected to A0 to read the change in the voltage level. And let's put the cursor at 0, 0. And let's just write light level. Then LCD, that print, and now we're gonna show that end value, which is the one that I'm taking from here. It's the ADC read that I'm doing. Let's upload it. And as you can see, it's reading 130. If I put my finger over my light, it should be going down. Oh, I know why. Because I wrote this into my setup. So that's why it's just doing it once. If I wanted to do it continuously, I need to put it in my lib. So let's give it a try again. And let's do the ADC there. So let's put this here. Now it's doing 130. Now it's too fast for the screen to see it, so we need to add a small delay. I'm gonna put a delay of 200 milliseconds so that we can have enough time to see it. 130. There you go. Now let's put our finger, and you can see how it's going down right when I put my finger there. That means that the sensor, it's lowering the voltage level. So usually it's 130, and when I put my finger, it can go up to almost 0. Okay. Let's try now to turn on the light if my voltage level is low. So if my N is below, let's try maybe 100. If it's below 100, let's turn on the LED that we have here, and that LED is attached to pin number 6. So we have to do a pin mode here, right? Let's call it LED. But I need to define that. So let's just define it here. LED as pin number 6, which is this pin right here. So if my N is greater, it's below 100, which is when I put my finger, it goes below 100. Let's turn on the LED. So digital red, LED, and let's make it high. right? Otherwise, if it's below over this level, let's turn it off. So else it's all right. LED low. Now let's give it a try. It's turning off, turning on, turning off, turning on, turning off. So it's working. Now let's add an indicator using our LCD screen. So we're gonna put a message in the part that's here below. So let's put LCD set cursor at 0,1. So that's the row that we have below, and let's just print lights on. Okay, and we're gonna do the same thing, but we're gonna say lights off. Let's give it a try. So now it's saying lights off because I have my light level over 100. If I put my finger, it's gonna turn on the light and it's gonna tell me that the light's on. And that's how example 2 works.